All right, here we are again. We're pretty similar to the last video that we did, was solving equations. We're going to solve what we call literal equations. Literal equations are when we're actually not, when we've got more than one variable in there and we're solving for one of those variables. The reason why we can't solve it all the way because we've got more than one unknown that we don't know. So here's a couple examples. I don't know x and y, and anyway. So this is a skill that's actually pretty useful to be able to manipulate equations and move them around is really what we're doing here. It's going to be pretty similar to just solving equations. We're just trying to get everything away from whatever variable we're looking for. In this case, we're going to look for solve for y. And yeah, that's what we're looking for right now. So, okay, so this first one here, I've got negative 7x plus 2y equals 12, and we want to solve for y, which means I want to get this y by itself. I want to move the negative 7x and the 2 and get it away from this as well. What I want left is just the y on the side by itself. So we're going to do this really similar. We're going to take care of the addition, subtraction, and then the multiplication and division last. So this, I need to get rid of this 7x to start with, and so what I'm going to do is just add 7x because of this negative value here. So I'm going to add it to the 12. Now I can't combine those two because they're not the same terms. So all I'm going to do is write it as 12. Actually, we'll go this one. It actually doesn't matter, but we'll go 7x plus 12. You could go 12 plus 7x. And then on the left-hand side, I'm just left with 0 plus 2y is what I'm left with. This is good because I've got only just the 2 left. Now I'm just going to divide this by 2. I have to divide the whole thing by 2 here on the right-hand side. When I'm done with the left side, I just left with 1y. So 1y. And then on this left-hand side, I'm going to divide the 7 by 2, which I'm just going to leave it as 7 over 2x. Okay, if you want to go 3.5, that's all right, but I like to leave it as a fraction. And then plus 12 divided by 2, which is 6. And that'll be my final literal equation. Now I've just put that and solved it for y. The reason why this is useful right here is you guys have seen this when you've graphed lines before. This is just an equation of a line is what it is, and you can graph it now by hand, whereas when it was in this form you wouldn't be able to do that. So let's do one more of those. So same idea, I'm going to move this x first by subtracting it, okay, because the sign out front of the x is subtract. And so I'm going to go negative x plus 1 on this right side, and then on the left side I'm left with 0 minus 8y, but I don't need to put the 0, obviously. Just redundant. And then, and math is just our lazy, we don't want to put the 0. And then I need to get rid of the negative 8, so I'm going to divide by negative 8. That leaves me with just 1y on the left-hand side. And then I have to divide the negative 8 to the negative x, which this is just negative 1, guys. So that's just going to be 1/8 x, because negative and negative makes it a positive here. Again, this is negative 1x here. So that's why I just did 1/8. Okay? And then I'm just going to go 1 divided by negative 8, which gives me negative 1/8. And there you go. Bada bing, bada boom. That one's there. So again, this just puts it in that y-intercept form that you can graph it with. Okay. Let's look at a couple others that are a little bit different. These are more with areas stuff. So for this, for example, this top one, that I'm looking at, I'm going to try to solve this one for b here, this middle variable. So I need to get rid of the 1/2 and I need to get rid of the h. Now if you look, the operation that's happening here is this is all times. You just don't write it. Whenever there's no sign between them, they're all together. There's timesing, so it's 1/2 times b times h. So I like to get rid of my fractions first. And if you remember from the previous one, to get rid of this fraction, I'm just going to times by whatever the denominator is. So my denominator is 2, so I'm going to times by 2 here, because that'll leave me with 1 times 1, which is just 1, right? And I'm left with BH here. And I do have times this side. Forget this comma. Sorry about the comma there. But that's just 2A now, or 2 times A. However you want to write it. We just usually write it as 2A because I don't have to write the time sign. And then the nice thing is I'm trying to get B by itself, so I need to get rid of this H. So I can just divide by H. It's just like if that was a number that's 7 or 10 or 23, like how would I get rid of that that's timesing to it? I just divide it. Because H divided by H, whatever it is just going to be 1. Okay, if that number's 3, then it'd be 3 divided by 3, which is 1. If it's 10, then it's 10 divided by 10, which is 1. Okay, so I'm just going to be left with B on that side, which is what I wanted. And then on this side, because this H doesn't go in evenly, I don't know what any of that is. I'm just going to leave it as 2A over H, and that's perfectly fine. If I wanted to find the base of this is actually the area of a triangle, but if I wanted to find the H, I just take 2 times the area and divide it by the height, is what those variables represent. Okay? This next one's the area. This actually should be volume. This is the volume of the sphere, but we'll just do A that's all right. We'll just use A. So we're going to solve for R in this case. So again, I've got this fraction, so I'm going to get rid of that denominator first. So I'm going to times this by 3, which will leave me 3A on the left. And then on the right, I'll be left with 4 pi R cubed. Now I want to get rid of this 4. So I'm going to just divide by 4. And you could actually do these in both in one step if you wanted to. You could divide by 4 and then divide by pi. You could put these together because they're both numbers. That is perfectly fine. No problems there. And then I've got this R cubed is the only thing I have left here because this just gives me 1 R cubed. And then over here, I'm just going to leave it as 3A over 4 pi because it's all divided by that. Now the trick is to get rid of this cube. To get rid of a cube, we're going to use a cube root, guys. I'm going to use a different color so you can see this, so you know what I'm talking about. Cube root is the root with the little cube here. Okay? And again, I have to do that to both sides here so that it'll negate that or get rid of this cube. So when I do that, I'm just left with R on that right-hand side, which is nice because that's what I want. And that means on this side, I'm left with the cube root of 3A over 4 pi. So a little bit messy there, but again, you can manipulate it however you want. If we wanted to solve, I guess for pi, you could do that as well. But pi is a number already, so that would be pointless. So anyway. Again, solving for literal is pretty similar to what we were doing solving equations. Just solving for specific variables. So, alrighty. See you later.